So, hello everyone, this is Jose. I'm the partner technology strategist for Microsoft Hong Kong. And so welcome to the Microsoft Online Forum. And in this section, I'll be covering the different deployment options when you want to deploy your apps to the cloud, which is Azure. And then I'll cover the tools or the options as well as what are the consideration factors when doing it. So with no further ado, let's get started. So yeah, um, welcome again to the Microsoft Online Tech Forum. And in this section, we'll be covering the options for building and running your apps in the cloud. So just as a quick introduction, we'll be using Tailwind Traders, which I believe you have already heard a lot of times from other sections, which is our virtual company to illustrate the scenarios as well as the tools. And in this section, you'll see how we can make use of different technologies like Visual Studio Code, the Azure portal, or the Azure command line in order to build a secured application that can run and scale on Azure, which can be in a form of a virtual machine or just as a web apps in a PaaS kind of model. So just a heads up, there are so many different kinds of tools and materials that you can make use of when considering deploying your application to Azure. So the first rule of thumb is that there is no single bad choices. There are just choices that is for each right scenario. And so feel free to explore all those options or the tools after today's sections. And you can see that each tools have its own useful scenario. So this will be a quick agenda for today's sections. So first of all, I will talk about the deployment tools that you can make use of when developing or deploying your apps to the cloud, and then the different kind of deployment options, such as hosting your application directly as a VM or hosting it as a container on Azure. And then I'll also include some security features that is pretty important for your application on the cloud. So let's go through the tools first. First of all, we have the old and classic Visual Studio. It's pretty big, not only for the install size, but also include for its capability. It already have a lot of tools installed inside Visual Studio, so it's a complete IDE. That means that you can directly develop your code on Visual Studio, and then with a click of a button, you can push that application to Azure. And you don't need to install any like additional extension or add-ons in order to do it. So yes, it supports multi-platform, including Windows and also the Mac OS. And again, it's no longer just for a .NET application. You can actually do Python, do JavaScript, do all sorts of stuff in Visual Studio. One of the best part of it, or a new extension, is called the Live Share. So I'm not sure whether you have heard about Live Share already. It's basically what allows you to do co-editing of code with another user. So imagine that you are doing pair programming, and your partner is sitting somewhere else in another office. So what you can do is make use of live share and then live share all the code that you're developing on with that partner. And the partner does not need to install any environment related to that code. They only need to install whether Visual Studio or Visual Studio Code. And with the live share extension, they can directly co-edit and comment with you based on what you have been developing on. It's just like a pretty similar experience of co-editing or co-authoring a PowerPoint or a Word document. Next off, we have Visual Studio Code. So the best part of Visual Studio Code is pretty lightweight, even compared to Visual Studio, and then it's pretty extensible and customizable. So you can install all kinds of different extensions into Visual Studio Code. So for example, if you are developing on Azure App Service, you can install an extension for Azure App Service. Then you can directly deploy and monitor your application to Azure. And then it support all different kinds of language or syntax. And there are tons of extensions just for doing the syntaxing or just for having a better layout for the Visual Studio Code. And last but not least, you can also directly run your terminal and your command lines inside the Visual Studio Code. So for example, if you want to SSH into your cloud VMs, you do not need to open another Windows for PowerShell or Bash. You can directly do it inside VS Code. And yeah, so for Visual Studio and Visual Studio Code, those are both kind of the UI options for you to do your deployment options. Then we also have some kind of command line tools, which is the PowerShell, the HSCLI, as well as the Cloud Shell. So I believe some of you have already heard about PowerShell or the Azure CLI. It's just basically another module specifically for Azure deployment. So you can install that PowerShell module, and then you can directly run PowerShell command to create different resources on Azure or monitor it. And in case you do not want to open a command line windows on your desktop, you can make use of the Cloud Shell, which I can just do a quick demonstration here. Yeah, here's the Cloud Shell icon, and if you click on it, you can open a Cloud Shell directly in the browser window. And then after you see that I connected, I can just I can directly run the command here to list the resource group or create different resources just inside the command line here. So next time you hang out with the friends, you can just directly log into the Azure subscription, and inside Azure portal, you can do different kind of command line stuff. So let's go back to the presentation. Oops, not this one. And yeah, we know that it sometimes can be really frustrating or time consuming for you to click through each and every single steps when creating new resources on the Azure portal. So we basically have a set of features called the ARM template. It's pretty similar just to Terraform, where you can deploy all kinds of Azure resources or a huge bunch of workload by defining a JSON template. So you can see that the ARM templates actually have the same extension as JSONs, but instead you can actually put comments in it about what resources you actually want to deploy. And then next time you want to deploy all these kind of resources, you just have to import the template and then quick deploy, but not have to click through each and every single resources one by one on Azure portal. And if you are eager to learn more about how the template is defined, here's a quick link where you can see all sorts of templates and tutorial on doing so. Yeah, and we also have a lot of documentation for you to understand how the ARM template works, as well as how to do different deployment. So here will be the links to the documentation, and feel free to check it out after the session. So now that we talk about the tools that can be used to deploy to Azure, let's talk about the options of deploying to Azure. So first of all is the Azure Bob Statics website. The best part of it is fast and extremely cheap. You're basically hosting your HTML, CSS, and JavaScript file on our Azure Blob Storage. That is not an application server, so the result is that this hosting is pretty cheap, up to just like a few dollars each month. And you may say that in before, what you can do with static websites is pretty limited because it's just pure HTML code. But right now, with today's like JavaScript framework like Angular, React, or even Vue, it's pretty easy to create complex solution just using static websites. So if you just lead a lightweight applications and there's not too much robust logic, then static websites on Azure Blob Storage would be a pretty good option for you. And then next off, we have the platform as a service, the web app options. So basically, it's called an Azure App Service. You can host your API app or your mobile app, your web app, which basically your web page onto Azure App Service. But today we'll focus more on the web app. So the best part about Azure App Server is that it includes a lot of features from the Azure platform, like the scaling, the backup, or the DR, and much more. So it supports both Linux and Windows and a lot of language, like .NET, like Java, like Python. So it's like the familiar things that you have been doing on premises with the application server as well as the client side serving the static content. So this is the second option for deploying your app to Azure. And then next off, we have the containers. So there are two ways to deploy your containers to Azure. One is the Azure Container Instance, other is the Azure Kubernetes Services, AKS. So for Azure Container Instance, ACI, is allow you to really quickly to deploy your container image and host it on Azure. So this is the best part if you need something that is, if you need to spin up a container really fast, just for a short amount of period, then you may want to make use of Azure Container Instance. And if you need more containers or if you need to host a bunch of microservices, the Azure Kubernetes Services, AKS, would be the better and the best option for that. So let's see some scenarios where actually containers or AKS can be pretty useful. So one of the use cases is lift and shift. So with containers, this is the best way to avoid the problem that the developers say, oh, it's supposed to be working on my machine, but how come it's not working on the cloud? Because by containerizing your application, you can remove the issues caused by lack of dependency or lack of libraries. You can just deploy it everywhere, whether it is in Azure, on premises, or even just on edge device like IoT devices. And also another use case is for microservices. So when you're building a huge application with a lot of tons of features, it's a good practice to break it down in different microservices. So you can do that with AKS by hosting different microservices in different nodes that can basically both all interact with each other as well as the main applications. And then lastly, maybe for machine learning, that sometimes you may just need additional containers to process the data or to do some analysis, but you don't need that application to be running all the time. So the best way to do would be just quickly spin up a container, and then after you have performed your workload or do the analysis, you can just quickly delete it. So after we've talked about containers, web app, platform as a service, as well as the static web page, let's go back to the most traditional way of doing things, VM. I believe all of you have been working on VMs, whether it is on premises or on cloud. It is a pretty well-known technology, and it requires the least amount of configuration if you want to considering migrating your application to the cloud. Because with a VM is running on premises, there's most likely the chance that it will still run on cloud, and it support a lot of most technology and give you the flexibility because basically you're just using infrastructure as a service on Azure. And also we provide options such as deploying the VM in the scale sets. So which that means that the VM can scale out based on the traffic or based on the amount of computing resource needed. So for example, if you have a Black Friday sales, then the VM can automatically scale out to multiple instances in order to accommodate the increased traffic. And most of the time, you don't want to configure or to set up the VM from scratch. So we have a lot of shared VM image, which you can directly deploy into your VM, such as if you want a MySQL on a Linux Ubuntu, then you can directly create a Linux VM and then select that image. And then after the VM is created, you already have a MySQL environment that is set up inside the VM. And then you can also create your own image based on your own set of VM. So let's say you have created a web application and hosted it in a VM. You can export and create that as a image later on if you want to replicate it in another VM. So let's see a quick demos about how to create the VM scale sets. So basically, all you can need to do is just create virtual machines and select virtual machine scale sets. And then I can create a new one. So you want to select which subscription and which resource group you want to put this VM scale set into it. So I just take as a test temporary name. This one to region. So here you can select whether it's a scale set VMs or virtual machines. So for scale set, you can handle the scaling of the VMs automatically or by defining your own rules. And then inside, you can select some of the most common image that you want to deploy for the VMs in this scale set. And of course, again, like I mentioned, you can select your own image, like from here. I have a Tailwind Trader demo image here. And then I've divided this image. I only need to set up the VM's accounts and the administration information, etc., etc. So due to the time limit, I've already created a VM scale set here. Oops. Yeah. I'm not sure why it's called failed, but it was running right before. So I'll just quickly go through what is the capability of a scale set. So the main features lies in the scaling options. You can see that you can automatically you can manually scale up the application into different kind of instance, up to 100 instance for a single application. Or you can customize the auto scale policy. Like you can see, add a different kind of rules to determine when should the VM scale up. Like for example, with the percentage of the CPU is over, let's say 80 or 70%, then you automatically create a new instance or to scale out in order to cater for the additional amount of computing resources needed. Yep. And then if I go into the instance that is actually in the VM scale set, you can see that I have currently 2 instances that are running in this VM scale set. So if I go into one of them, it's basically just one single virtual machine. And I can connect to it using all kinds of ways that I prefer, including remote desktop or SSH. It really much depends on your options. So currently, because it's delocated and I accidentally stopped it, so I don't think I can demonstrate exactly how to connect it. But it's basically just like connecting to any other VMs that you deploy on premises or on the cloud. So that was the first one of the demo of the options for hosting your application on VM, right? So next off, I'll also try to demo what's the experience if you choose to host it on a platform as a service instead, which is our Azure App Service. So again, if I go back to the Azure portal, I can select the app service that I've already created. And you can see that it's already running. Just like if I open the, yeah. Maybe something is wrong with the configuration. Oops, I'm not sure why it's not running. I can also open another instance. Just give me a second. So good thing that I have a backup of this web application already deployed in an other app services resource. So you can see that inside this web services already it gives you the URL for the web application. So you directly just need to click on it and then you can link to it. And of course, you can attach your own custom domain name to the application if you prefer to do it that way. And like the VM scale set, it already provides you a lot of scaling options, which is the scale up or the scale out. Scale up means increasing the level of the hardware specs for this app service. That is like increasing the amount of memory or increasing the amount of cores. So you can see that I can upgrade it to different options, or I can also downgrade it to different options if I don't need that configuration, of course. And then I can wise do it in just like what I did in the VM scale set. I can manually scale out the app service, like up to 30 instances. And of course, I can again create the scale out rule so that I can automatically scale out based on CPU usage or other condition. So this is the flexibility and advantage of using a web app. It's pretty quick to deploy and it still provides you with the scale out and scale out option. And inside this web application, you can actually see the configuration link. This is where you can actually configure all the environment variables that the application need to be used. And yeah, you can define everything from here, including like the SQL connection string. So after two quick demonstration of how you can actually host your apps in VMs or web apps, let's talk a bit more about the security features for hosting your application on Azure. So here's a typical scenario. Imagine you are starting off to develop a new applications. And of course, you have some secrets or API keys that's associated with this, including some database connection strings or some API keys, just like the cognitive services API key that we can use to call the AI, pre-train the AI model on Azure. And the easiest way to do it would just be simply store those things on a notepad and then include those in your application wherever you want, right? Then let's say that your business have grown pretty successfully and you need to include a few more developers for you to do your project. So you just directly share with them the secrets in a group chat or basically share the notepad file with them. Then now things like are really taking off. Then you have like even more developers coming in. And you have to divide the application into different environment. For example, that development environment, the QA environment, as well as the production environment. Meaning that you have a different set of secrets or API keys for each set of environments. And up to this point, it's pretty messy. You need to manage all those secrets, and it's pretty hard to do so because you have been previously just sharing them directly in chat or just sending in them through your messaging software. And one day, one of the developer is doing his coding at a coffee shop, and accidentally someone take a photo of his screen, like his chat. And inside there, he got all the assets and the API keys as well as the secrets that you use for your application. So that's a huge disaster, right? And we want to avoid it. So what features on Azure can you actually make use of in case you want to keep control of all the application secrets that you need to use? Let me introduce Azure Key Vault. Azure Key Vault is the cloud services that is for standardizing the safeguarding of encryption key and also safeguarding the application secrets for your cloud applications. So it supports clear separation of duties. For example, one security officer can be introduced to create the key vault, as well as choosing the logging mechanism or the recovery options, and then importing all those application secrets into the key vaults. And then he can assign different permission to other users. For example, such as the app developers. They only need to know the set of secrets for their own environment. So the security officers can actually just directly assign those permissions that they need to the key vaults. And then they can use those store the secrets inside the key vault directly. And then he can also assign another role, such as for the auditor. He can assign the auditor the only permission is to view the logs of the key vault, like which application have used the key stored at what time for what purpose. So in the end, using Azure Key Vault, you can standardize the safeguarding of your application secrets, as well as separating the duties of different parties in your organization. So in general, Azure Key Vault helps you to organize and manage all your application secrets in one place, including your connection string, your API key, your certificates, etc. And then you can seamlessly move between like different development environment, whether it's a UAT environment or the production environment. And then you can manage the access or update everyone's access in just one single platform. And these are the compliance certification that has been acquired using Azure Key Vault. So it complies with several industry standards and certifications, and it have already attained and acquired some third-party auditors and gain their endorsement of the services. Those auditor report is actually available on Azure Trust Center, and please feel free to check it out if your company have that specific concern. So let's see a quick view of how you actually can secure an app with Azure Key Vault. So for example, going back to our Tailwind Trader application, I want to configure the environment variables. Let's say for MongoDB, I've directly specified the connection string in the configuration, which is not pretty safe, right? Because the developer may accidentally share this secret or this string with other people. But for the SQL connection string, I'm actually using a reference from the key vault. And you can see if I edit it, it's actually referring to a key vault location where I've stored the key. It's currently said that the access is denied because I haven't defined the appropriate policy. I'll just go through it in a bit. So this means that I can actually go to the key vault service and check out how my key is actually stored. For example, here, there's a secret. Let me see that I have a secret named Tailwind secret. And then inside there is a identifier secret for my application, which is also running on Azure to connect to it. And of course, basically it's storing a connection string to the SQL Server. So this is how you actually reference the Azure Key Vault instead of directly entering your application secrets or connection strings into the application environment. So at this point, you may ask, don't you need credentials or need an account and password to access the key vaults? So that's like a chicken and egg problem, right? So does that mean you still need to manage an additional set of credentials in order to get the key value from Azure Key Vault? You're right. However, that's where the beauty of cloud comes in, because both your application and Azure Key Vault are already registered on Azure. So like I mentioned, you can define different policy that allows each and individual application to define which application that is allowed to access which sets of app secrets. So for example, I can define that only my Tailwind Trader web app can access the SQL connection string inside Azure Key Vault. And then after I'm doing this, it's actually exposing a local host endpoint for that Azure applications for it to get the valid credentials. So nobody can call this endpoint outside of the machine, which means that in the end, only the application that is defined in the policy can actually have access to the value stored in the key vault. And this is pretty much automatically managed because all of the services are running on Azure. So in the end, what if you don't want to have all your everything of your stuff on cloud? We understand that maybe for some data or for some features, why you may still want to host it on premises or even on another cloud vendor. So this is where we can have Azure, the beauty of Azure comes in. We provide a lot of different integration services that you can use to connect with both on-premises and cloud data source. For example, you can make use of a service called the Azure Logic Apps, which it can be interacting with our on-premises data gateway, which allows your application on cloud to actually connect with your on-premises data source, including on-premises SQL Server, on-prem Oracle Server, or on-prem SAP, etc. So when you consider to move your application to the cloud or develop a new application on the cloud, you doesn't have to think that it's a zero or 100 or zero or everything approach. You can move bit by bit of your services or your application to the cloud, and then remains those things that you want to stay on-premise. In Microsoft, we are always promoting a hybrid cloud approach rather than forcing like all our customers or partners to move everything on the cloud. And this is something that you should really keep in mind. So this will be pretty much it for my section. And just in case you have any question, please feel free to leave them here. And I hope that you have all been enjoying the experience in the Microsoft Online Platform so far. And if you have any technical ideas or issues encountered, just feel free to search me on LinkedIn or ping me after this session. Thank you so much.